will share my screen. Okay, looks like the screen has been shared.
Wait. Yes. Okay.
Can you see my screen?
Yes, I can see your career talk, the first page. Okay.
Okay.
So let me do a short introduction.
Okay.
Okay. So today, I'm very glad that you're able to make it here to join us for an inspiring session with Mr. Ong Teck Siong, a seasoned engineer and now manager with over 2 decades of experience in the semiconductor industry. Starting as a circuit designer at Intel in 2003, Mr. Ong has worked through technology advances from 90 nanometer to today's cutting-edge 3 nanometer nodes. Currently, as Intel's cache memory design manager, he leads a team developing critical components for Intel's next generation system-on-chip products. With a patent in memory design, multiple technical publications, and experience as an internal technical paper reviewer, Mr. Ong brings valuable insights into the skills and qualities that make a successful engineer. This session will focus on his personal journey, real-world challenges, and the excitement of working in an industry shaping the future of AI and technology. Please learn from Mr. Ong's unique perspective and practical advice for launching a career in electronics engineering. And I hope you ask a lot of questions during this session because it's very, very difficult and rare opportunity for us to be able to invite Mr. Ong with us, right? So I let Mr. Ong take the floor now.
Okay, good afternoon, everyone. Welcome to this career talk. My name is Teck Siong. You can call me Teck Siong. And I'm coming from Intel Malaysia Device Development Group. Okay. Today I'll be sharing with you some of my career journey, and my sharing is going to be go alongside with some of the history of Intel's products that I'm involved in, and some history of my department. So because this thing is my career journey is completely entangled with all this Intel history. So if I were to share it alongside, I thought it might be interesting. Okay. Um, Now, before I get started, I would like to thank Eileen for this invitation. Okay, thank you, Eileen, for visiting us in 2022. That time, the COVID has just ended, and the society has just been reopening, right? And thank you for visiting us. And also,
For
thank you.
bringing me around. That's my first visit to Intel.
Yeah, welcome again when you have time. And also thank you everybody who is attending today. Thank you for your time. Thank you for the lecturers who are joining us today. Okay. Now I would like to make this session a bit more interactive. I understand asking everybody to unmute might be a bit difficult. There are so many people in this session. So throughout the session, right, I may pop out some questions, and if you thought of would like to participate in answering or giving me some reactions, you can type the character as I was asking you to as I was asking, right? For example, if I say if I pop a questions and I say how many of you have experienced this before, and then you would like to give me a reaction, you just type a 1 and then you just hit enter. Then I have my chat box open here. Yeah, I see many people typing. Yes, that's the kind of interaction. It really helps to motivate me for my talk. Okay, thank you so much. Thank you so much for your reaction. So there will be questions like that going on, and later you can give me some reactions. Thank you so much. This is really helpful. Okay, now let's give it a try. See whether our reaction things works or not. Right. Uh, let me ask you all, would you like to have a 1 minute tour of the office environment that I'm working on? I'm currently in a meeting room. I would like to take a 1 minute step out of this meeting room with my camera on and show you how this my working environment look like. If any of you would like to see that, give me a reaction, right? How about a number 2, right? If you type a number 2, give me some reaction if you like to see that. Yes, yes, thank you so much. So I'm going to unplug my external monitor for a second so that I can walk away from my desk, and I'll just give you a walk. Now, there's a link that I have sent to Eileen this morning. She must share it with some of you. That link will give you the full view. It's a video in Facebook that you will see a full view of my working environment, high resolution, very clear. But the one that I'm going to show you may not be that clear because my webcam may not be that clear. But anyway, I'll just walk around for 1 minute and let you have a look. I'm going to unplug now. Let me take this down from full screen, unplug, and let's go for a walk for 1 minute. All right, so this is a meeting room that I'm in. This is a very typical meeting room. I have Mark over here. Hey, Mark. Hi. Mark is my staff. He's joining and getting some experience for giving a talk. Maybe the next time he will be the one who is giving the talk, okay? A typical meeting room will have a monitor, webcam, speaker, and then there's this whiteboard. This is one of the most important tools where we do brainstorming. And if I step out of the room, you will see these are the typical cubicles. Each of these cubicles are adjustable table. We are now in the share cubicle mode. That means we do not have one single permanent cubicle for every single engineer. Whoever that come earlier, he will get to grab the cubicle first. So if you like to sit on the hot spots, right, you will have to come early. And this is the launch. Okay, this is the launch. There are water cooler and also place for you to sit down and relax, and okay, for you to have some discussion, right? This is the place we call the lounge. And there are plenty other meeting rooms here. There's one right behind me. This is a much larger meeting rooms, larger than the one I came out from just now. Okay, and yeah, some more meeting rooms, and people are doing meetings inside. Okay, just a quick walk, right? There are a few more others launch like the one that I showed you just now around the building. I'm at the 3rd floor, and I have just showed you one of that. Okay, so I'm coming back to my room. That's the 1 minute tour. Hope you seen something, and if you'd like to see more of the whole office, right, use the link that I share with Eileen, and you'll get a high resolution view of the whole office. All right, I'm plugging back into my external monitor.
That's a very nice tour. And then we are missing the basketball field, I think, and some sports amenities, which they can see later in the Facebook link. Not now, but later.
Yes, the basketball field, yes, is one of my favorite place. So Eileen, are you still able to see the full screen view?
I can see your let's go for a 1 minute of this virtual tour.
Is that the full screen view?
Yes, it is.
Okay, great. All right. Okay, let me adjust my notes a little bit. Okay. All right, I have my notes on now. Okay, let's move on to the next slide. Right, a bit about myself. I am born and raised in the capital of Malaysia, Kuala Lumpur, and I graduated from the Sheffield Hallam Universities. It's a twinning program with the Tunku Abdul Rahman College. I've been in the semiconductor industry for 20 years. I started as a memory circuit designer. I worked as a memory circuit designer for more than 11 years before I take a leap into the synthesis design. Later, we'll talk more about that. And being a synthesis designer, that actually bring my career to become a technical lead, and as well as a manager's since year 2020. Okay, the technology process node that I've been through, I started with the 90 nanometer, and I completed my 3 nanometer project last year. And now I'm working on the next technology process node, which I cannot tell you. Shh, okay, I'm just kidding. Okay, it's this is a confidential stuff, but okay. Yeah, that's a very brief thing about me. This is a picture of me and my family in Thailand. This is Chiang Mai, the national park. Very nice place to be. Now, this is one big map about the history of my department. Okay, you do not need to look too close or pay too much attention at the moment. We will walk through some of the events that happen, and later I'll flash this slide again at the end of the history segment that I'll be sharing. Basically, this is the 65 nanometer. That was actually the 90 nanometer. That was the time when I joined Intel, and my department started from the 90 nanometer as the first project that we involved in. And until today, we are now at the 18 Armstrong. 18 Armstrong, in other words, is the 0.18 nanometer. Sorry, 1.8 nanometer. Okay, but they changed it to a different unit name. The products that we've been through, including the Intel Pentium products, and then later they rebrand it to become the Intel Core, and then they have changed the brand name further to the Intel Core Ultra recently. Those are the brand name, right? Let me go more details onto the history. Now, in the 1990s, Intel was very popular for the product series called the Pentium. Can I get some reaction of who have heard of this Pentium product before? Because it has been quite a while. If you heard of the Pentium product before, can you type a 3 into the chat? I just want to see how many people actually, number 3, right? Number 3. How many people actually know about Pentium product?
Not bad, no?
Yeah, then you must be old enough to hear about this. Okay, thank you so much for your reaction. This is the one of the 1990s product in Intel products, one of the most successful product that make Intel the company today. And this is the time when I joined Intel. Okay, Intel started with Intel Pentium, Pentium Pro, Pentium 2, Pentium 3, and then Pentium 4. So as you can see, I joined Intel sometime at the end of the era of the Pentium 4 products. So that is the timeline when I joined Intel. The department that I'm in actually involved in one of the last architecture we use on the Pentium product. Hey, is that a question?
No, I don't think so. You
Okay.
unmuted.
Yeah, that was a year 2003. That was a year I joined Intel, and that is the first product that I was involved in when I joined as a graduate trainee. That was a Pentium 4 architecture. Now there is one product line by Intel that I would like to mention here, but however, my department and myself was not involved in this product line. Now I have to mention this product because it has a very big impact of how we use computer today. Okay, the product line brand name is called Intel Centrino. Okay, it was started around year 2003 to 2005 when it was first launched. Why I want to mention this product, it's a very first product that enabled the laptop computer. Okay, essentially what one of the biggest difference that they made during that time is they integrated the Wi-Fi chipset together with the CPU. Okay, in the past, Wi-Fi chipset, Wi-Fi is essentially another card slot that you slide into your motherboard, or it's another independent piece of card that slide into your laptop motherboard. It is much higher power consuming, and is also less efficient. Now, Intel made a big leap by integrating the Wi-Fi chipset onto the CPU, right? Put it next to the CPU, and that really make a big difference. How much difference are we talking about here? Now, this picture that I just show up here, right, is what people call laptop in the past. Okay, can you imagine this is the laptop in the olden days, right? And it was slowly evolved into something that looked like this, that is still looking very gigantic, right, for our standard today. And then slowly it starts to evolve again further. At least now you can put it on your lap, right? Right? And then it becomes something that even closer to what we have in the modern days, and finally become the laptop that we all know today. Okay, so that's why I just want to make an honorable mention on this product, even though I was not involved in this product, but it really make a big difference in the way we use computer today. Okay, now moving on. In year 2006, right? In year 2006, there was a time when Steve Jobs came out with a very very thin and light laptop, which at that time nobody have seen such a thin laptop before. And the name of this product is called MacBook Air. Okay? It's a product that is still selling today. Okay, so that is also the year when Apple decided to use Intel microprocessor. Okay? In the past, all the Apple laptop was powered by the Motorola power processor. Okay, that processor is not powerful enough for the kind of software that Apple would like to run, and they make a very big decisions to work with Intel so that they can make their laptop powerful and also very power saving. That was the year of 2006. Okay, that was a year he presented the MacBook Air, and subsequently, right, there were multiple generations of Intel microprocessor that goes into Apple product. Now, two of the product that I want to mention here is one is the code name, the project code name is called Haswell. It was on a 22 nanometer process node. It was the year 2013. And then the second product called Broadwell, 14 nanometer, 2015. These were the two products which my department and myself was involved heavily in designing these products. Okay, if you consider the whole full chip in the whole full chip die, right? The Penang design team has at least taken up 1/3, if not half, of the ownership of designing this chip. So it's a very significant contribution by the Penang team, by the Malaysian. It's something maybe you may find it unbelievable, but actually these things were designed and produced by Malaysians like you and me. Okay. In fact, one of the very dumb question I asked my interviewer when I was in my interview to join Intel. He was my senior director. He's the person who hired me 20 years ago, right? During the walk-in interview, he was telling me that he was designing Pentium processor. Then I was a bit shocked. I was a student. I don't know a lot of things. I just asked him, are you serious? You designed the Pentium processor? I couldn't believe that. Like I was quite shocked that wow, our Malaysian engineers are actually doing this, and it's really feel very proud uh, that our Malaysian engineers are actually capable of doing all this. Now, the the Intel later they make a new brand, which is Intel Core, which is the product that you're still able to buy today, like the Core i3 and i5 and i7. Now all these are just the Intel branding. So behind the scene, we upgrade our architecture and our process node frequently in different architecture, different generation, right? And but they all branding under the Core i3, i7, and i5 products under this branding. So all the subsequent Core i product, many of them my department and myself were involved in. Now, a bit more about myself. As I mentioned earlier, I started as a memory circuit designer. You might be wondering, okay, what do a memory circuit designer actually do? So, if you open your textbook if you look for anything related to memory, typically you'll see a diagram like this, right? Rows and columns of bits that you can store 1 and 0, right? This is a typical way of imagining a memory. So my job is to design the whole memory from scratch, basically. So I need to, for each of these small little square box, which represent 1 bit, so I need to design the circuit that will store the 1 and 0. Okay, whenever you need to write a 0 and a 1 into the bit, how do you design a circuit that will electrically, transmit the information or the charge into the memory bit, or how do you discharge it? So this is one of this is my job. I would also need to design the decoder. I'm sure many of you, some of you, especially the year 4 student who are with us today, you must have seen the decoder before. So this decoder will decode out the one hot signal that will select, right, like a pointer, right, point to which memory entry that you would like to read, right? These are the things that I do, I design, okay? And once I finish designing all this circuit, I have to put them onto the layout. So for those who have taken the VLSI elective, you might have seen this kind of picture before. This is literally layers of metals that we draw on the layout to construct the circuit. Okay, this is just an abstract view of how the circuit look like. This is how the actual physical view that goes into the silicon. Okay. Now, just one disclaimer here: all the pictures and photos that I'm showing on all my slides, I just snip it from the internet. Okay, none of this is anything that I took from my project or Intel confidential document. So I just took it from the internet. The purpose is just to illustrate what I want to say. Okay. So now, once you put all this information, once you put all this onto the layout, you need to extract all the capacitance and resistance, and then you simulate it in the SPICE simulator in order to make sure that the circuit meets the timing that matches your initial intention. Say you want to run this you want to read and write this memory in a 1 gigahertz clock cycle. You have to simulate it in order to know whether it meets that performance or not. Okay? So that is also part of my jobs. And because of all these experience that I acquire over the 11 years of time, right? I was lucky enough that I got to file a patent, and the patent was accepted by the US Patent Office. So today, if you go to Google Scholars, you look for my name, you'll be able to find 2 patents that were filed by me and my peers. The other one is another publication in the IEEE conference that was also published together alongside with my peers. Okay. Then I took a leap on the 12 years of my career, right? 12 years, the number 12 years, right? I took a leap into the design synthesis. That means what is design synthesis? We'll discuss in more detail in the coming slides. Um, but basically, what design synthesis means is that we no longer draw the NAND gate, the NOR gate, the transistor one by one by hand. Right? In the past, I have to draw those gates one by hand using the circuit drawing software, and I can't remember exactly. I probably might have drawn a few thousand gates in a week or a month, and then simulate them. But if we go into a synthesis design, the tools can synthesize a million of gates in a matter of hours or days. Okay, that is the kind of scale that we are talking about. Right? So for every NAND gate and NOR gate that I show you in the previous slide, right, they are just one single dot on this diagram that I'm showing you. Okay. Again, this is not a real design from Intel. I just snipped this from the internet. Every single dot that you're seeing, purple color dot that you're seeing here, it represents one gate, one NAND gate or NOR gate or inverter that you normally study in the textbook. And you can imagine how many of them over here on this screenshot over here. And what are all these big rectangles? They are the what we call the macro. That means they are some kind of analog circuit that cannot be synthesized in a digital form. So the circuit designer will draw them and harden them before we place it into our design synthesis. One of the best example will be the SRAM that I showed you just now, right? So the SRAM that I drew in the past actually become a macro cell for the synthesis designer. Okay, so that is also part of the reason why I've been assigned as a cache memory synthesis design technical lead and manager, because I had the experience of designing what goes into each of these macro. I know the circuit inside the macro. So when I'm synthesizing my design with all the SRAMs, I will be able to know what is the strength and weakness of each of the SRAM and how should I interact with the SRAM. Okay.
May I know what do you mean by synthesizing? That means you draw it on the layout and then you actually run and see the characteristics, is it?
Nope, nope. So for example, if you follow my mouse, say this side is the input of my uh, digital logic, and this side is the output of my digital logic. What I'm supposed to do is I will draw the pins on the left side in as my input pins, and I will draw the output pins on the right side. I will define their placement, okay, and then I will define what is the timing that I expect them to traverse through. Say I give them a 1 nanosecond timing, and then all the logic that's supposed to go in between has been coded in a Verilog. All right. And then we will ask the tool to synthesize the Verilog into a circuit, and it must also meet the timing constraint that I set. It must also meet the placement constraint of input and output that I set. So I'm basically constraining the tools to do the job, but I don't do the job. That is what I mean by design synthesis.
Thank you.
Did I answer your question, Eileen?
Yes, thank you.
Yeah, I consider this a big leap in my career because if I have not took the leap into learning synthesis, I would still be a circuit designer today, which I would still be drawing maybe hundreds or thousands of gates by myself, by hand. Okay, I may be categorized into a analog circuit designer. That is also one unique domain in our industry. But however, because I took the leap into embracing the automations in my industry. So now here I am today. I'm the cache design technical lead and manager. Okay, so this is the kind of leap that you will go through in your career. So this is one of the big leap that I've been through. Um, guess what is the next leap in our industry? You know? Who wants to make a guess, right? I mean, after design synthesis, right? What would be the next leap in the semiconductor industry? Anybody want to make a guess? You can type a single word in the chat group, like what suddenly goes into your mind as you were hearing from me now. Let's see. Manufacturing, fabrication, AI. Yes, you guys got it. AI would be the next leap. Okay. There are companies who are looking into how to get the AI to do this for the engineers. Even if it's not completely the whole thing, but at least assisting the engineers. Okay. We no longer need to do every single thing ourselves, right? If any one of you have watched the movie Iron Man, right? You know that the character Iron Man, whenever he's developing something, there will always be one AI called Jarvis who is next to him, right? He will brainstorm with the Jarvis, talk to the Jarvis, and then Jarvis will help him to do some of the chores, right? That is a reality that is coming very soon. In fact, it's already here today. All right. Some of my daily work that I'm doing with my peers and my staff, we have our own Intel in-house AI, GPT, that we talk to the GPT in order to get to know our design. Okay, the architect has a lot of documents that they write. Those documents defines the architecture of our product. In the past, I have to read those architecture document in order to understand my design, so that I know when I perform the design synthesis, am I going in the wrong direction? Right? Am I synthesizing the design within the expectation of the architect? Right? In the past, that's what I have to do, and understanding the architecture document, to be honest, is something not easy. Okay, because the architect have their own way of thinking, right? They will write something that is very architecture centric. It may not be easily comprehended by other people. So what happened in Intel is that the Intel have created. I mean, they created an in-house GPT, and they dump all the top secret document into the GPT. So that's an in-house GPT that is protected. Okay, so the GPT comprehend what's in the architecture document. So I can talk to the GPT in order to understand. For example, I want to ask, what is this high-speed clock? What is the purpose of this high-speed clock? What does it relate to the other piece of the logic? How does it relate to the other piece of the logic? So I can ask relational question like this. Instead of, if I were to just read the architecture document, I'll read chapter 1, I'll read chapter 2. I probably will have no idea what's the relationship between chapter 1 and chapter 2. Right? But now I can relate it by asking the GPT. Okay, there is also a development effort in trying to see if the GPT can write the Verilog code directly. So that means we can they can if the GPT can understand the architecture document and write the Verilog code directly, then I can take the Verilog code and directly go into my synthesis. Okay, so there is a lot of exploration that is going on. That's why I said the next leap is actually the AI. It's not just a fancy word that we read on the news. Okay, so I'm going to the next slide. So being able to leapfrog into the design synthesis, I was lucky enough to have participate in one of these projects called the Meteor Lake. It is actually the very first Core Ultra product. For those who stay tuned to Intel products in the market, Core Ultra products just came out last year. Okay, what happened here is that you must have heard of the word SoC, right? There was a trend in the range of year 2010 to 2000 now 2020. People try to put as many logic onto a single piece of silicon. Okay, a single piece of silicon, which they call it SoC, system on chip, right? So what they want to do is they want to take every single logic function on the motherboard and put it onto one chip. Okay, but there is limitation of doing that. There's a physics limitation, right? If you build a silicon that is too big of piece, the chances of some of the transistor failing is very high. Okay? It's a very statistical game. You either can make the whole piece of silicon work correctly, or some of them is a defect. So if some of them defect, you have to throw away the whole piece of silicon. Can you imagine you take one whole week to fabricate the silicon, and at the end of the day, it was functionally defect and you have to throw it away. Right? There's a lot of high cost. So the industry, including other company like AMD, they have moved into this multi-tiling approach, where they carve out a piece of logic. Actually, is the CPU logic, the one that perform the computing, and the other piece of logic, which is doing the graphics, and the miscellaneous logic, the one that handles your keyboard, your USB, your PCIe, your hard disk. So they segregated these logic into different piece of silicon. Okay, so that the failure rate, as the size of the silicon becomes smaller, the probability of failure rate is also getting smaller. Okay, and that is what we call the Tau architecture. Okay, so I was lucky enough to once again stand at this point of the history of our industry. For the first time that Intel is doing this TAO architecture, and I was participate in this project. I was designing the cache memory for the CPU TAO. Okay. CPU TAO is one of the most advanced TAO among all these among all these silicon chip, because in order to win a race, say today you open the news, again the news about Intel is winning against AMD is winning against Intel. So what are they essentially comparing? They are comparing the CPU compute strength. Okay, they are not talking about whether your USB is faster or my USB is faster, your keyboard is more advanced or my keyboard is more advanced. What they are talking about is the CPU. So if you want to win the race for the CPU, your CPU must be at the most advanced architecture and the most cutting edge process node. However, the rest of the silicon, you can use an older process generation. There is no rush for you to go to the cutting edge, and an older generation of process node has another advantage, is that the yield, we call it the yield, YIELD, the probability of getting a good chip is much higher because it's a very mature process. Right? It has been in the market for 4 or 5 years. We know how to make those things, and so if you put these less important logic onto a totally different die, chiplet, you do not need to spend the money, premium money, or paying for these less critical logic. Okay, so that's the Meteor Lake. And coming back to this slide, just to conclude the history of my career and my department, right? So what I just walked you through was we were in the CPU business in the era of 2000. CPU is just a CPU. It doesn't do the USB, it doesn't do the rest of the function on your motherboard. Okay, it was only up to the time around this period of time, year 2010 and later, that's when we go into the SoC, where we start pulling in as many logic as possible on the motherboard onto the system on chip. Okay, and then here is the Meteor Lake that I was mentioning. This is the very first product that has the tiling architecture, and subsequently we are going to have a new. The current project that we are moving on would be also in a tiling architecture. All right, I will take a pause here to see if anyone would like to ask any question. I would take maybe 1 or 2 questions if there's any, so that while our memory is fresh
I think there are
about what I said.
three
Mm,
inside
mm.
the comment. They ask, is your
Okay.
GPT based
Mm.
off Llama?
I have no idea because my GPT is provided by my IT department. As far as I remember, I do have a drop-down menu on the side where I can choose OpenAI 3.5, 4.0. There is also Cloudy. Maybe Llama is also there. I'm not sure. But I have plenty of model that I can choose from. So I'm a electronic engineer, so those are not my expertise. I'm just an end user. Okay. So, but I'm very glad that I'm currently living in an era of being able to use this tool to assist my work.
There is
I
another
think
one
there's a
asking,
second question.
yeah, do you use AI to design or check? To design things or for checking purposes?
Currently, the AI has not been fully integrated into my engineering tools yet. I know the EDA company, the Electronic Design Automation company, is trying their best to integrate that, but it has not been productized yet. So the only time I will be using AI is when I need to, like I mentioned just now, query the architecture document. That is one example. The second example is if I need to write something, some scripts, some quick scripts to get my engineering work done. Say I have a typical example is I have a 2 gigabyte of CSV file, comma separated value file, or a 2 gigabyte of log file that I need to parse through in order to get to know what's going on. I need some scripts. I cannot read those file line by line, right? I need to use scripts. And so if I need a Python scripts, I can ask the AI to write for me. I just need to describe to the AI, for example, in my log file, I will have this pattern. You help me to grab out all this pattern and help me to count how many lines do they occur. Then the GPT will write me the Python scripts, and I'll apply the Python scripts into my work directly.
Okay, thank you. There are a few more very long technical questions, or do you want to keep them to the end for the 4th years?
Okay, sure, yeah.
So we can move on a bit about the skills that are because those are very technical. So I think maybe we keep it to the end a bit lah.
Okay, whatever you say, Eileen. Now I'm going a bit on the non-technical part. So if for those who follow the news, you might have seen a lot of news that talks about semiconductor. Right? Why is this industry so often being mentioned in the news? Okay, what are the news that you have heard of? So let me show you a few examples here. If you have been reading the papers, you might have seen some of these news. Now, can I see some reaction? Or how many of you have seen some of these news before? Right, give me a number 4 in the chat. All right, so looks like our year 1 student are also very much tuned in into the news. Very good. Yeah. So what's going on? You see, US wants to sanction the China. They don't want to let them buy the technology. Malaysia has been talking about setting up semiconductor R&D hub in both Selangor and Penang. And the state governments, including Selangor and Penang, has been investing heavily, subsidizing heavily, right? And some people, and an author, his name is Chris Miller, even wrote a book about what's going on in the last 10 years about this the fight on the chip and semiconductor, right? So what really is going on here, right? It's something that I would like to discuss with you all today. So let me just go to the next slide. Now on this chart here, you will see that this is something I got from the Edge financial newspaper. Okay, this is on the Edge financial newspaper. They are showing an incremental sales of the semiconductor market. Okay, that means there are this much of transaction value that is going on in the market, and this chart here, the scale of this chart is a billion. Okay, billion US dollar. That means whatever number you see here, you add 9 zeros behind. That would be the number that we are talking about. Okay, 1,000 billion means $1 trillion of transaction is going through the semiconductor market by the year 2030. Okay, that's what people are projecting. And there is a very huge talent war going on around the world. If today you are a semiconductor industry engineer, you can literally work in any of this country if you want to. Okay, the government will be very much willing to write you a visa and let you stay and work there if you want to. Okay, so that is how intense is the talent war that is going on in the industry currently. Okay, the because the academia cannot produce so many talent so quickly, right? These are all human. It takes time to build and develop. I'm sure the lecturers in this room would fully understand, uh, internalize what I'm saying here. So, and this is one of the reason, right? Let me give you 2 reason, okay, why this market is so hot, right? What are the driving demand for this industry? Okay, so number 1, of course, is the AI chip, as everybody might have expected. Okay, this chart is showing you how much transaction is the AI chip is going in the market. We are now here in year 2024. You might think that, oh wow, Nvidia have sold so much chip, Intel has sold so much chip, AMD have sold so much chip. This is like a crazy market. So many people spend so much money, right? Microsoft, Meta, Google, Amazon, all of them are spending a lot of capital expenditure on buying all these AI chip. You might think that that is a lot, but if you look at this chart, if you compare this year and the projected coming 10 years, you will find that whatever spending that we are spending today is just the beginning. Okay, there will be a lot more spending throughout the whole world by big corporates as well as countries on this AI chip, and you can see they are break down into spending on CPU, which is what Intel make, GPU, which is mostly what Nvidia make today, FPGA. I'm sure many of the year 4 students know about this. And then the ASIC application specific IC and others chip. Okay, so every single segment is growing. Even the old ancient CPU segment, right? You might think that if AI is becoming so advanced, nobody is buying a PC computer anymore. That is not true. Okay, in order to do the AI computation, you might need a lot of GPU, but at the same time, you also need a lot of CPU as well. So every segment is growing. Right? So this is one big driving factor, and there's a lot of money that goes into it. That's why every country, every company is going after it. Okay. What would be the next factor, right? Anybody can think. What will be the second industry that will be very much demanding for semiconductor chip supply? Right? Who wants to make a guess? Oh, what do I mean by AI chips? AI. What do I mean by AI chips? It means the computer that can answer your ChatGPT question. Okay, when you ask a question to ChatGPT, this what it actually goes in is a series of neural. I'm not an expert in this field. So you go into the computer chips to compute based on the knowledge that it has and give you an answer, and that whole computation requires all this whole stack of chip: CPU, GPU, FPGA, ASIC, everything. All right, somebody gave me some idea: military, automotive, data center. You all are correct. Okay, most of all of you are correct. And the second example I would like to give here today is the automotive. Yes, you're right. So there was actually another picture, infographic picture I couldn't find. It shows you how many percent of a car today is really mechanical and how many percent of the cost is really electronics. I still remember that picture in my mind. I just couldn't find it. It's actually about 30 to 40% of a car today. The cost of a 30 to 40% of a car today goes into electronics. Okay, a car is no longer purely a mechanical machines anymore. So electronics. Look at all these labels here. These are all electronics components that goes into a car. Okay, so in year 2023, when there was a shortage of chip supply, it was so serious that companies like Toyota and Volkswagen, all the big car manufacturer in the world, had to stop their production line because they are not getting enough chip. Okay, so you can see how severe as how much impact a chip is there on automotive industry. Okay, um, it it is a very big volume. Okay, can you imagine every single car on the street today, which is still every single old car on the street today is going to be replaced by a electronic dominated car, right? And every single one of those cars will demand for many chips, and hence that goes into the demand for the industry, right? Which is the first chart that I show you. Why? I hope I answer your question of why there is so much demand for the semiconductor industry. Okay. Now, I have a third example in my next slide. I have a third example, which I don't see any answer on the chat so far. Okay, none of your answer is related to my third slide. Who would still want to try? What is the third chip demanding industry that is coming soon in the coming next 10 years. There you go. Good, Hazim. Good guess. Good guess. It's robot. Okay, it's robot. Let me go to my next slide. Yes. Look at how many robots is there on in the market today. Okay. Whatever showing on this chart is not some prototype robots. Every single one of these company is racing towards producing in a mass production. Okay, it's just a matter of time that they finally finish verifying the quality, the safety, and all the fact. Once they meet all those requirements, you're gonna see all these robot walking on the street. No joke. Okay, uh, just imagine a few years ago when we will start talking about having a robot at your home, okay? Sweeping your floor, mopping your floor, right? Can I see like how many of you have a robot at home? Type a number five, right? Type a number five in the chat if there is one robot, at least one robot in your home. Okay, great. You see, today you have a robot sweeping a floor for you at your home, right? Then what is stopping it from washing your dish and washing your clothes? I'm sure Eileen would like to have one too at home, right? If there is one
To fold
that is selling, sorry, Eileen,
to fold clothes.
to fold clothes, yes, that's the hardest thing to do at home, right? If there is one of this robot selling at an affordable price, listed in Tesco or Lotus or Aeon, I'm sure many of you would consider. Okay, so it has always been like that, right? About 15 years ago, when I was in US, the very first sweeping robot company is called the iRobot. At the time, one piece of iRobot cost $1,500. Okay, you can only dream about it, right? Then after 15 years later, right? Today Xiaomi is selling the sweeping robot for less than 1,000 ringgit. So that is the trend. That is possible, right? That is possible, and that is a trend. And so this robot standing in your home is just a matter of time, and it's going to be very soon. Okay. So yes, how many chips do you think we need in each of these robots? There's going to be a lot. There's going to be a lot of chips need, because each of these robots needs to carry a brain in it. It needs to be autonomous. It needs to be able to do the work, and each of these chip can carry the model as big as a llama or medium-sized llama model, in order for them to be able to do the work autonomously. Okay, so yeah, a lot of factory is waiting and see how and when they can replace all their factory workers with all these robots. Okay, these robots can work 24/7 non-stop. They will not complain. They don't have worker unions to strike in front of your factory. They will not need to sleep. Okay, and they you don't need to pay them salary. Okay, so every manufacturing factory company is looking closely into making this happen for their factory. Okay, I have seen one demo by the SanDisk company, and have anybody hear about the word the memory company called SanDisk? They make a lot of memory for the digital camera or memory card, right? They bought over by Western Digital. So the SanDisk factory in Penang here, which is about 20 kilometers from here, their factory is fully autonomous. Okay, their factory manager once showed a demo in a conference where all the robots are walking around carrying the memory chips for one testing to another testing machine, uh, completely autonomous. Okay, and the whole factory floor is switch off, no lights. They call it lights off manufacturing. Okay? I was so impressed when I look at that video, because the whole factory floor is completely dark. There was only a few LED blinking here and there. It was a whole factory floor that's completely autonomous, run by the robot. And that is already a reality a few years ago. Okay. All right. I am going into the something more related to the career. Okay. I would like to describe about the spectrum of our semiconductor engineering. I'm going to put it in a very high level, okay, very high level. But you guys can ask me question later. You see, in order to build a semiconductor chip, right, it all starts with the architecture definition. There's supposed to be one more arrow behind here, which is the marketing guys. We have marketing. Every company have their own marketing guys who talk to the customer. Right? The customer will ask for the features. Say the customer say, "I want USB 5. I want PCIe 6. Can you do it? I want DDR7." So customer always wants the most cutting edge, right? But the problem is whether we can manufacture it or not. So the marketing guys will take in all the requirement and hand it over to the architecture team. They will define the architecture, and somebody is going to write the Verilog code. These people, we call them the micro architecture team. They will write the Verilog code to materialize the algorithm. And then there will be another side pairing team who is the pre-silicon validation team. Because when you are writing a Verilog code, there is a very high chance that you will induce some bugs into your code. Just like the Python programming code that many of you are writing, right? There's always bugs, produce a wrong result, produce a inaccurate result, right? So there's a side-by-side team called the validation team who will validate the RTL code that is produced by the micro architecture team. And then after that, it will be the physical design domain, which is where I'm in. Okay, I'm the physical design engineer. I will design, synthesize the design as I showed you earlier, and then I also check the performance of my synthesized design, whether my design can go up to 4 or 5 or 6 gigahertz. I have to run simulation in order to verify that. Yes, Igwan, you have a question?
Go ahead.
All right, I'll continue. Yeah, so after all this physical design is completed, we will send this whole completed design database to the factory, and that's when the factory will produce that piece of silicon that will put into the package. Okay, so most of the time when you are looking at a product from a electronic company, that is where this is what you are seeing. This is the completed product. Okay, so there will be again another validation team. They will take the completed product and validate it to make sure that it's able to hit the functionally correct, and also the frequency can hit the 4 to 5 or gigahertz or the clock speed that they want. This whole team of people will also be the one who write the test program that will be sent to the factory floor, which will assemble the silicon onto the package, cover it with the aluminium cap, and then they will test it with the test program that was written by this group of people. Okay, there were robotic arms inside the factory where they will pick up the chip and put it to the tester and test it for 5 seconds to confirm that this product can really function, and they will put it into the bin that will be shipped to the customer. For the non-functioning chip, they will just put it in a different bin, which will then be discarded. So these are all done automatically under the factory floor, right? And then finally, they will market the product. In case you're wondering why I use the word tape in and tape out, right? This is a classic word that we use in the semiconductor industry, because in the past, if I need to send multiple gigabyte of data to the factory, right? There is no internet 30 years ago, and there is no thumb drive, there wasn't even hard disk 30 plus years ago. There was no hard disk, right? How do people send information across from one place to another? They use this type of tape. These are magnetic tape, right? Cassette tape. Can I see a show of hand? How many of you have seen a cassette tape before? You can type number 5 into the chat group. Have you seen a cassette tape before? Magnetic cassette tape. Yeah. All right. Great. Yeah. These are the medium that we use to store lots of information, digital information in the past. Great. Thank you so much for your reaction and response. Yeah. But it's something that we no longer see nowadays. Okay. So that's why we use the word tape in, right? So I heard from the old story from some of the older engineers, when the design is completed, when they finish, saved into the tape, they will lock the tape and handcuff it onto one of the engineer. And then the engineer will take a plane from California to the Oregon, and then send it to the factory. A chartered plane, right? That whole plane is going to be ride by that one engineer only. So that was how things were done in the past. Right. I will go deeper into this circle portion of the domain. I stole one slide from my peer. What's going on in this microarchitecture, physical design, and post-silicon validation here? So this is what we do. As I mentioned earlier, there will be people who write the Verilog code. We call it RTL in my department. RTL, when you see the word RTL, it means the Verilog code. Okay, we'll write the Verilog code. They will build it. They will produce the quality checks before they hand it over to the validation guy. Remember the validation guy I told you? So this group of people, their principle of working is everything is wrong until I validate it. Okay? That is the principle of working. So they are always against the RTL guy, right? Because they check, they are the auditor for the RTL guy. So and then after that, once everything is validated, they'll hand it over to the physical design team. We call ourselves the back end team, which is the part that I'm working on. There will be people who draw the analog circuit. There will be people who perform the synthesis. The SD stands for the synthesis. And after we produce the chip, there's this big arrow that go to the factory and come back, and then this post-silicon team will then do the post-silicon validation, right? The whole process is supported by the two groups of people. They call themselves the Design for Testing, DFT. This group of people, they will design a lot of small circuit that goes into our synthesis. Okay, they will write a separate RTL. For example, for the fourth year student, you might have heard of a concept called scan chain. You chain all the flip flop together so that you can shift in the logic and shift it out again for testing. So that is done by the group of DFT colleague. They will write the RTL that goes into the main logic, and then they will also be the one who produce the pattern for the post-silicon guy to verify that. Another group of people who is supporting us is the design automation team. They are the one who write the scripts and the flow to do all the jobs, all the tools that I'm using. I don't use the tools directly from the EDA vendor. I need to, these tools will need to be stitched together into a flow in order for the engineer to execute it. Let me take a pause and drink some water.
Too much already.
Right. So if you're buying a computer today, what kind of spec would you consider, right? What I pasted here is a typical computer spec that you can easily find on the internet or Shopee. If you want to buy a microprocessor or computer, most of you might be looking at how many core does my computer have, what is the frequency that it can run, and how much cache that this has, right? These are the typical thing that you will consider, if you want to buy a computer from the Shopee or Lazada, right? So in the next slide, I'm going to show you how these things get, how is this thing relate to the design work that we do. Okay. Oh yes, the GPU, right? The GPU is here. This is the Intel integrated GPU, yes. But I'm going to talk more about CPU since I'm a CPU designer. Okay. So as I promised earlier, what does it go into the synthesis design in details, right? In a nutshell, physical design or synthesis design, however you want to call it. There will be RTL. There is a RTL code that is given to me, right? This is a Verilog code. I'm sure the year 4 student might have seen it before. I will take the Verilog code and synthesize them into gates, okay? And the synthesis tool will one-shot synthesize it into the layout as well, okay? Besides synthesizing the gates, it will also synthesize it into the layout. But the screenshot that I'm showing you here is just the normal, the old hand-drawn gates, okay? But in the real synthesis world, there will be a millions of these gates, okay? And they all get synthesized into the layout. And as a synthesis designer, I will need to check and verify that the timing, the static timing is meeting, right? The timing that go from one flip-flop to a second flip-flop is meeting the gigahertz timing that I'm supposed to meet based on the product definition. So if I don't meet this timing, you won't be able to buy the product that is like 2 gigahertz or 3 gigahertz. So when you look at the product that says, let me go back to this slide again. Yeah, the product that tells you, this product can run up to 4 gigahertz. Essentially, what they're telling you is that the circuit inside this product can run up to 4 gigahertz. Right? The inverse of 4 gigahertz will be was it 250 picosecond, right? So you only have 250 picosecond to go from one flip-flop to the next flip-flop. That is how tight is the timing simulation that we do. Okay, this is just timing simulation, right? What you see is a square waveform, is a very nice square waveform. But on the actual silicon, if you use a probing machine to probe onto the silicon, this is the kind of waveform that you get. Okay? The square waveform that you learn on the textbook will actually manifested in the waveform that look like this. Okay? This is the real waveform that you see if you probe onto the silicon. So as you can see, right, getting a nice digital waveform is really hard on the silicon. Okay? That's why there are a lot, tons of very stringent design rules that the synthesis designer will have to comply to. For example, we call it the slope or the transition time of the square waveform. It has to be sharp enough. If I have a very bad transition time, so I take 10, 20 picosecond or 50 picosecond just to transition from 0 to 1, you can imagine how this waveform is going to look like in the real silicon. It's going to be really, really bad. And at the end of the day, you don't even get a 1 here, right? Maybe this waveform come up to here and then will come down again. You did not really achieve the logic 1 that you needed for your function. Right? So that's why there's a lot of design rules and the timing that we need to meet. And that's how, when you put millions and millions of them together, that's how you can make up this one piece of silicon. Okay. So this screenshot I took from the internet. This is actually the Meteor Lake compute tile. Each of these box that you're looking at here is one CPU, okay, one CPU. So there's total of 6 CPU that you're looking at here, 6 performance CPU. And then over here, there is the small CPU. We call it the Atom CPU. There are 4 of them. So there's a total of 4 Atom CPU, and there's another 4 mirror over this side. And then all this memory here from here, you see this big piece of long rectangles here, and also here all the way up. These are the cache memory. Okay, if I go to the previous slide just now, the cache memory, okay, that is what you are paying for. Okay, that is what you are paying for, which is the cache memory. And that is what the design that me and my team work on. That's why I call myself the cache memory designer. Okay, all these blocks is owned by me and my team. Okay, I hope this small, quick introduction gives you helps you to connect, right? How you see the spec on the market versus what we do as an engineer in order to materialize those. Let me take a sip first. All right. For the coming few slides, we'll talk a bit about you as a student, how to connect you as a student to the engineering career that we are working on. It is becoming less and less technical. It's more about how do we need to prepare ourselves to becoming an engineer. Okay. Here are a list of few qualities of I would would like to see in my staff, right? If I were to hire an engineer, right, what are the things that I would like them to have, and what would I coach them to become? That is what I would be sharing with you. Okay. Details, attention to details. Okay, there is a lot of information in our daily work. Okay, gigabytes after gigabytes of simulation log files that you need to go through. So the attention to the details, the ability to recognize certain pattern, uh, and also collect the data is important. Okay, if you look back on the ancient history of human, right, we how did we become what how did we get all the advanced technology that we have today? It all started from basic thing like, observing the stars, like how the sun move, how the stars move, right? Those are all the very basic ancient thing that human mankind did at the very beginning, right, before they even have science. And they recognized the pattern and slowly invented the technology one after another, right? So the pattern recognition ability is something is required as an engineer. You collect the data and then you organize all the raw data into informations, and from the informations you connect the dots, the facts, so that you can start defining problem statements, right, that will solve your problem eventually, right? This nice picture I snipped from the internet really summarize what I want to say. Okay, you have raw data. Most of the time, you have plenty of data, and how do you label and categorize them into information? How do you connect the dots to make it useful information? And then from there, you further develop your hypothesis, right, into a problem statement, and then you prove your hypothesis and you solve your problem, right? Some examples I can give you. Smartwatch. I'm sure many of you wear your smartwatch. Xiaomi or Garmin or Apple Watch. Do you know that those manufacturer has been 24 hours collecting your physical fitness information and upload to their server? Are you aware of that? Uh, Anybody aware? Can you type a number 6 into the chat? Are you aware that your information has been consistently, even when you are sleeping, if you are wearing it, they are collecting all those information and upload to their server? Yeah, so everybody aware of that. But do you have any idea what are they doing with your data? Why do they want to upload all your data onto their server? They can use those data for many purpose. It could be used for medical studies. It could be used for their next generation product design ideas. There can be a lot of usefulness of it. That's why data. Some people even say data is the new generation of oil or petrol. Right? If you own the data, it's almost like you own the petroleum in the last century. Okay? So they are taking your data to uh, to optimize their next generation of product, or as well as some of the corporate that is maybe less integrity corporate. They may even sell your data to the third party. Maybe there are medical research team that needs the data to prove their thesis. They need a lot of data to prove their thesis. Maybe they'll buy from some of these manufacturer. Who knows? Right? You don't know how are these manufacturer is using your data, right? After all, you agree for them to use the data, right? You click the agree and click yes, right? When you sign up for their account. Okay. Other example I can give is like the CCTV. The CCTV in your corridor, in your dormitory. I know our Malaysian government may not be that advanced yet, but if you go to country like China, right, your face has been continuously recognized by all the CCTV around the whole country, and how they are using the information, you never know. Okay. The Also the Waze and the Google Map. I'm sure many of you, when you drive, you always turn on the Waze because you want to know what's the traffic in front of you. right? So you all this information has been used by the corporate, right? So the question back to ourselves is like, there are many data surrounding you, even you as a student, right? As a student, there are many data surrounding you. How are you utilizing those data? How are you utilizing it for your thesis? How are you utilizing it for your capstone projects or your quiz? Right? How are you connecting the dots? How are you recognizing the pattern? That is the quality that I'm looking for an engineer. Next quality is about communicate and collaborate. Okay, uh, one person will never know it all in the current modern era of society, right? There, even if I ask my chief architect, he may not know everything. Okay? He needs, even if he know everything, he can't do it all by himself. Okay, our society and our technology have become so sophisticated that you have to collaborate with somebody in order to get your objective done. Okay, so that's why it is important to communicate and collaborate. You do not live in the jungle alone. If you are not a team player, then it will be very hard for you to be effective being an engineer. Okay, use these magic questions during the appropriate time. Ask sincerely, is there anything I can help? Pop this question. If you pop this question at the right time to the right person, people will really appreciate you. They will remember you for a long time, and you will also learn something while helping others. Okay, and of course, the on the reverse direction, don't be shy to ask for help when you need it. When you really need some help, or you need some things to get done, or you do not know how to solve the problem, don't hide it, right? Don't cover it. Uh, do ask for help from your peers or people whom you think that can help you. Right? One story I can share with you is when I was a fresh graduate. When I first joined Intel, right, I was working on one of the Pentium 4 product. One of my peer, he was too shy to ask. Okay, he was being assigned a block of design to work on. Uh, Everybody work on each other's blocks, but when it comes to time to approaching the tape in, still remember the tape in word that I mentioned just now. When it comes to approaching the tape in, then we realize that my friend, he has not completed his work, and he don't know how to complete his work, but he did not raise his flag, he did not raise his hand, right? So the effect is that the whole team, the whole project have to delay because this one person did not communicate. Okay, so he could have raised his hand and said, I need help. Okay, I don't understand this, can somebody help me? If he were to do that, right, uh, I'm sure many of the team member would be willing, very much willing to help, and then we will all be able to be successful in that one project without any delay. Okay, that is one story I can share. Right. Listen is a very deep word. A lot of us hear a lot of things, but we are not listening. You may think that you are listening, but you may not be. It's like for the last 1.5 hours as I'm speaking here, I don't know how many of you are listening. You may be hearing what I say, but you might not be listening. I will skip this part since we still have a few more slides to go. You can go check out some of the uh, self-development information about listening. Okay, is one of the very key thing that we need. Drivership. Okay, in the world of business, right? Everything is forward, right? Imagine how many iPhone Apple produce every other year, right? How many Samsung S22, 23, 24 people produce every year. Uh, the After I show you how sophisticated is the process of manufacturing the product, right? But yet this company can still produce this product every year. How did they able to make it? It's actually a lot of driving strength, drivership within the company, right? Things have to be move forward very quickly, very fast, and that's the kind of attitude we need from all the engineers. Get it done, get it done, get it done. And if you need help or you have no idea, let's brainstorm. The meeting room that I show you just now is the place where we talk, we draw, we write, we debate, and then we find the best idea out of it. Right? We do it very intensively. We ask each other critical question. Hey, do you think this is really going to work? Have you considered this? Have you considered that? So these are the things that we ask each other, right? So that we verify that the solution will work. And once everybody agree with the solution, right, we set a deadline. Okay, we set a deadline. When are we going to get this done? When are we going to get together and discuss again for the next milestone? And we follow up and follow through, right? If you are assigning something to somebody, you follow up, follow through until you close the loop. Okay, close the loop. Right? You assign something to somebody, the person has to come back to you and tell you that I'm done, or come back to you and tell you that I have problem. Close the loop. Okay? You do not just assign a task and you forgot about it. Okay. Never stop learning. Okay. This question is meant really not meant for students. I know students learn new things every day. Okay. It is a more a valid question for old engineers like myself or my peers, right? We have to keep asking ourselves, when is the last time I learned something new? Okay. uh, that I think there's a lot of people that got a not so right concept that when I graduated, when I stopped being a student, I can stop learning. So I totally disagree with that. You have to keep learning. Okay, you have to keep learning, and you have to keep reminding. I have to keep reminding myself, when is the last time I learned something new. In fact, I never stopped learning ever since the day one I joined the industry. Right after I finished 90 nanometer, the whole industry moved on to 65 nanometer. Then I have to learn again. Then the whole industry joined to jump to the next processor and the next. I never stopped learning. I once upon a time I told one of my friend, right, hey, look at the guy who make the barista who make the coffee in a kopitiam, right? He can make the same coffee for 20 years and customer will still come to him, right? He don't need to learn anything new. But I guess that's not true anymore, because nowadays people sell copy in a very innovative way, right? They franchise their business. They make a lot of perks out of it. So if you are still selling copy the same way like the 20 years ago, probably you have no more business today, right? When was the last time I created something, right? A lot of engineers, if we do not remind ourselves, we will just keep doing the same thing again and again. We follow the company SOP. We do the same design again and again without stopping down and think that hey, I can actually do this better, faster, or easier in a different way. Okay, so engineering never stop evolving ever since the first day I joined until now, and we could easily get obsolete very quickly. Okay, imagine if I did not take the leap into the design synthesis, I would have been obsolete today. Okay, and if I do not take the leap into the AI, I would be obsolete tomorrow or yesterday. Okay, so if you have doubt, just ask yourself, how can I get this done faster, easier, cheaper? You can ask this question to yourself for your capstone project, for your thesis, for your quiz classroom project. Right? How can I be different from my peer? Right? Everybody in the same classroom produce the same circuit, the same simulation waveform, the same report. I think Eileen will also fall asleep when reading all the reports, right? And if there is one report that look different, that come up with different idea, wow! I mean, Eileen will really sit straight and read this report carefully. What is the idea behind this, right? And then I'm sure this student will get a much higher score compared to the others. Right? So how can I get this done faster, easier, cheaper? And maybe you can add one more word here: different. How can I do this differently? Okay. Yeah, you might see I like to type the word 3 times in my in the title of my slides, right? Because of this guy, he influenced me. I have to keep repeating myself to my engineer and my staff to the point that they feel I'm very annoying. Teck Siong, enough. Now. You do not need to repeat one more time. I hear you. Okay, so that's my style, right? I keep repeating the same thing again and again until they get annoyed. That's when I know they hear me. Okay. Uh, Along the same line, like how do you get yourself prepared? This is one of the questions requested by Eileen, right? I would say build your work portfolio. In other words, the actual hands-on work. Okay, so being a hiring manager, every time uh, I receive all the resumes of the fresh graduate students, one of the things that I will zoom in is your projects. I would like to know what are the things that you have done, right? During the interview, I will ask you a lot of questions about your work portfolio. I was hoping that the candidate can answer me in a very detailed way. Okay, like Mr. Ong, I did this circuit because I need a 1 degree turn for my motor, and in order to do that, I have to code this 1 millisecond of Python code. That level of detail is what I like to hear from the candidate. Right, that shows that you really know your project. Right, I also came across candidate who try to bluff me, right? Because he or she do not really know his work, right? He will just say, "Oh, I do this roughly like this. I did this roughly like that," right? That kind of candidate, I may just put them on the side on the KIV, and I will look for other candidate. So your final project, your capstone project, would be things that a lot of hiring manager will be looking for. If you are doing some personal hobby projects, you tell me that I assembly my own PC. This is my gaming PC. What are the spec of my gaming PC? I like to hear that, right? The very geeky stuff, right? That shows that you know. Competitions, right? Hackathon, robotics. If you are not the winner, it's fine. At least you participate. Tell me about your participation. Tell me about experience. I also came across one Indonesian fresh graduate. He's from Indonesia. He has been working on freelance job of writing Verilog code for customers in Russia. Okay, that's what he told me, right? So guys like this who is already working when he's in the student time, right? I have no doubt about hiring him. Okay, so that's how he's already working on freelance job, right? So why is this so important to the hiring manager, right? It shows the ability of you articulating your idea. You tell me all the details. It shows your ability to solve problem. Usually this kind of project, right? Either your capstone project or your competition, you will face problem, right? For those who, can I see a show of hand? How many of you been in any of these like hackathon or robotic competition? Can you type a 7 into the chat? I just want to see like how many of you have this kind of experience. Great. Many of you have been in this. So I'm sure you might have encountered experience like a minute or 5 minutes before the competition, your robot stops working, doesn't want to move, right? Or it doesn't move in the direction that you want, right? Like 10 minutes before the competition, oh, it was so frustrated, and you have to solve the problem within that 10 minutes, right? That's the kind of excitement and also the problem solving skill that you have, right? Though I will ask you questions like this, so you will share with me your experience. It's not really about how much you know, it's about the attitude and your ability to solve problem, how resourceful you are. If your robot stop working, what is the first thing that you're going to go look for? If you're missing one jumper wire, what are you going to do about it? uh, how resourceful you are, right? For the things and resource surrounding you, how are you going to grab it and solve your problem? Okay. If you're only given a chanko, right? What are you going to do with the chanko, right? These are the things that you need to think during the crisis. Teamwork. Are you a teamwork, right? How do you guys manage the EQ? Right? Many students that I came across, they were told me they have quarrel, they have arguments during the teamwork sessions, right? And how did you deal with it? Is something that I would like to know. There are some occasionally I will discover some natural leaders, right? People who do not carry any title. They are not being assigned as the leader of the team, but they happen to be doing the leader work. They happen to be the one who coordinate the work just naturally, and likes to listen to them. And those are the natural leader. Okay. Uh, very very often, right? Whenever we work or we study, or in life, right, there will always be choices in front of you, right? Very often those choices must be, one is the easier one to do and one is the harder one to do. Okay. uh, One of the question that Eileen sent to me, like if I were to live my youth again, right, if I become young again one more time on my life, right, what would I do differently? I would pick the harder path. I repeat again, right? I do not dismiss the harder part. Very often when there are option A and option B in front of us, we will choose to go for the easier way. It is a human natural thing to do. Okay, we always go for the easier way. But one thing I want to remind ourselves and also our friends here today, right? Don't dismiss the harder part. Don't like, oh, this is harder. Forget about it. I'm not going to consider it. No, let's not do that. Don't dismiss it immediately. Take a moment to think about it. Right? What is the experience I can gain from the harder one, the harder part? It can help me to sharpen my skill, and each of these skills and experience will become a compounding value to yourself. Okay, you'll become a more and more valuable person or engineer because you have this experience. I saw somebody unmute just now. Was there a question? Okay, no. So yeah, the harder part, right? The experience, right? This is also the reason why many of the royal family in the world, right, whether the UK or our own Malaysia royal family, they tend to send their next generation into the military. They send them to Afghanistan, right? Even just there for take a picture and come back, right? But at least they've been to Afghanistan, right? They can experience the hard things in their life, right? Next advice I have is this equation here. What does this equation means? The R represent the relationship and the E represent the encounter. It's just some fun equation I create for myself and my team. Encounter means, you meet somebody, you say hi, and then you say bye. That is a encounter, right? It's like if you move into a new place to live, right? You at the beginning you do not know who is living next to you, but every morning or every evening you meet that person, you're just like that, right? And one day, during Deepavali or during Raya, you say, hey, hi, balik kampung ke? This is the very first time you speak to that person, and that encounter value will increase, right? When you do this hi and bye, right, it was just maybe 0.1. But the next time when you speak to that person, right, you ask him, hey, balik kampung, mana kampung, you ask him question like this, the encounter is a larger value, maybe 0.1 or 0.8. When all these number adds together, it becomes the relationship that you have with that person. Okay, so you can either manipulate this equation or you let it happen naturally. What do I mean by manipulate this equation? So, if you want to build relationship with your lecturer, you just go stand in front of the office and say hi, good morning every day. Then your relationship will get increased. That is a more manipulative way of doing it. But that's how I have seen it. People surrounding you, your coursemate, your lecturer, your internship buddy, engineer, and manager, your teammates during your internship, the members from other team, uh, the company or the school social network, your badminton club, your chess club, and the leaders in these organizations that you are in. These are the people that you want to build relationship with them. Okay, you never know how they will be able to help you one day, right? Your coursemate, right? Your coursemate today, he may look very silly today, he don't comb his hair, but who knows, he may be the next Mark Zuckerberg. Okay. Last thing, right? This is the last thing about my sharing, right? Take care of yourself. Okay, take care of yourself. You must learn how to take care of yourself. You need to be mindful about the resources currency you have surrounding you, right? Resource currency. I like to use the word currency because these things can be exchanged. When I say the word currency, most of you will be thinking about this, right? I can exchange money. But do you know your time is also a currency? Is your time a currency? Think about it. Is your time a currency? It is, right? If you offer Eileen, I clean your toilet for 1 hour, right? She will offer you some money, right? That is a currency. Okay, you can exchange your time for money. That is a currency, right? You can also exchange your money for health. Right? If you do not take care of yourself when you are young, you sleep very late, you eat very unhealthily, you never exercise, you got heart attack, then you have to take your money to exchange for your health. Okay, so this is something that we all have to pay attention. There is many engineers whom I know have lower back pain because they sit for too long. I know there are engineers in our industry who die in their cubicle because of overwork. Okay, I know such a thing that happened. Okay, and I have friends who at around my age, which is 40 plus, who already passed away, a few of them, okay, because they have not been taking good care of themselves. So please take good care of yourself. And the last thing is your attention is a currency. Okay, your attention is a currency, and many corporate is trying to grab that from you. All the notifications on your phone is expanding your currency, is spending away your attention. Okay, is spending away your attention, and hence you cannot focus on your real work, and you need to be aware of that. Okay, so I always recommend people around me that turn off all the notification on your phone and only turn on the one that you need. Okay, turn off all the notification because it is spending away your currency. Okay, if you have 100 ringgit in your pocket today, you wouldn't go onto the street and just spread it across the street and say, "Hey, come take it, my 100 ringgit currency." You wouldn't do that, right? But why would you do it on your time and your attention and your health? So please be aware of these resources, and they are very, very valuable. And these are some of the books that you can look for. This is a book. If you want to become an engineer, I would really encourage you to take a look at this book. It's written by our Intel principal engineer, KL Pang. He's one of my friend. He wrote a book, and I have been reading the book halfway so far. I find it very, very useful for the first half of the book. It's very useful for young engineers. And for the second half of the book, is for the wisdom for old engineers like me. Okay. This is another book that I find it very useful until today. 7 Habits of Highly Effective People. If you have not heard about this book, you must go and take a look. At least you go to YouTube and look for the summary of the book. Okay. At least that's the least you can do. Right. And then finally, this book is called the superpower of 21st century. Okay, why did he say so? The time you spend on doing certain project multiply by the intensity of your focus will be equal to the quality of your work. Okay, so if you don't have the intensity of focus or you don't spend enough time, then the quality of your work will degrade. Okay, or you may be spending a lot of time, right? You work days after days, week after week, but you're not spending enough focus on it. Again, your quality of your work is not going to be good. Somebody's laughing just now. Okay. Yeah. The superpower of the 21st century. Really, if all the friends and your peers surrounding you has been distracted by all the social media, the notification on their phone, and everything else, right? You are the only one who can focus. Can you imagine how powerful is that, right? How much more you can achieve compared to what they can achieve. There were requests from Eileen to share a bit about what are the perks of working for in the industry, or especially for Intel. Actually, in general, in our industry, right, most of the company that you go to, you get medical benefits. That means if you walk into any of the clinic or hospital, if you are hospitalized, touch wood, you most of those will be covered, right? Uh, Dental claims, optical claims. Sorry, I misspelled the word. Optical claims for your glass. Those will there will be certain amount that can be claimed. Most of the company in our industry have these perks. Flexi hours and work location would really depend on the company. I know Intel is one of the company that has the flexi hour and the work location. So it really based on trust. Okay, if you are a reliable person, you are a trustworthy person, and you can negotiate and discuss with your managers. Like if you really need certain flexi hours for a specific reason, that is not a problem, Right? We are more result-oriented company. So and in fact, the whole industry is like that now. So it's a result-oriented. Right? If you can produce the output, no one really care where you are. As long as during the meeting, if there is a scheduled meeting, you must attend and you don't missing in action. That should be all right. There are free drinks in Intel. I'm sure there are many other company who have that. There are monthly food subsidy. In this batch here, every month, 80 ringgit will get reloaded into my batch, and I can just scan in the cafeteria. I can eat for free. There is massive amount of learning resource. I have access to IEEE Explore. I have Udemy training, LinkedIn Learning, O'Reilly. All these learning resource is available. Intel already subscribe it. Any of the employee can get it. Also, Intel internal conference technical paper. There are tons of innovations papers that have been written and been stored in a library. I can go and take it and open and read it. It's confidential, most of them, and because being an Intel employee, I can read and learn from there. Okay, then there are also other project related documents like the architecture document that I mentioned earlier, and also design document. When I do my design, I will draw the diagram and write the intention and plan it out before I implement it. And those documents are also stored in a central place. Even for the older projects, anyone can. If you have the access to that project, you will be able to look for those documents. Right, a bit of advertisement here. Intel part-time internship program. This is new this year. We are starting a new part-time internship program. There's too many information here because I copied this slide from my peer. You just need to focus on this slide down here. Today, most of you who attend this career talk is a year 1 student. We start taking in year 2 student as our part-time intern, and this part-time intern will be working with us on a part-time basis. It's like around 20 hours a week throughout 2 years, right? And then finally, when you enter the final year, we can even put you onto a different program. It's also a part-time intern program, but your final year thesis will be related to Intel products. And finally, once you graduate, if you meet all the performance criteria sets by the manager, right? The manager has the right to hire you directly as a permanent engineer, right? Without going through the graduate trainee process. This is one of the new program. I'm not going to go through the details here today. I will drop the email address to Eileen later for the admin whom you can contact. If you are a year 2 student, if you want to sign up for Intel part-time internship program, this is open for year 2 student. Yeah, this is a model that we copy from the Germany university. In case for those of you who do not know, for most of the German universities, their graduate students would start working for their German industry starting year 3. They will work through the year 4 companies like Volkswagen, Osram, Robert Bosch, right? And then that students will graduate and have a permanent job immediately after they graduate. That is the model that the German has been applying for many, many years. And we are copying that model.
上一次唱完歌啊，然后没有讲话。
Okay, somebody just unmute. Okay, for closing, I just want to show you some fun photos so that you don't think that engineers is just about work. Okay, so we have fun team buildings. We do things like these adventure rides. We play badmintons very frequently. We play Squid Games hosted by a vendor, and then we also play some games. Okay. Other activity, we go for bicycle rides, very famous for Penang Island. We go for fun in the river. We play pools. We have a pool table up there in the rooftop, and a big basketball court as well. And then we also have family events for the families as well. So those are the things that happen besides work. Okay. Yeah. For closing, this is the quote from our founder, Robert Noyce, right? Don't be encumbered by the history. Go do something wonderful, do something different, be creative. Okay? Don't be constrained by the environment or the SOP or the rules surrounding you. You are a creative engineer. You can be a creative engineer. All right, Eileen. Looks like we took more time than we expected.
Thank you.
Almost all the time.
Thank you so much for your sharing. I think from technical, very, very future, and then until what you have to prepare, what the students have to prepare from now. I think they have learned a lot and there are plenty of questions. Possibly besides those in the chat from before, maybe I give the chance for people who wants to switch on their camera and then you can ask directly. You can unmute yourself and ask directly the questions that you have.
Yeah, any question, feel free.
Otherwise, I have to go up there and search for your previous questions. Let me see. Yesterday we have one I sent to you regarding the restructuring. Let me check.
Yeah, there was a question that Eileen sent for me ahead of time. It was about all the cost-cutting news that related to Intel recently, and how is the engineering team dealing with it. Yes, to be really honest, all the things that you read in the news are mostly real. There is a cost-cutting that is going on in Intel because we are trying to build factories that will make a lot of chips that will be demanded by the industry going forward, right? I have shown you the chart of the projected demand for the chips, but all these chips needs to come from factory, and you need to build the factory in order to build these chips. Okay, if you don't have the factory, the effect is going to be like 2023 when we don't have enough chip supply and all those demand cannot be fulfilled, right? So what Intel is looking for is to build the future factories, and semiconductor factories are extremely expensive, right? They are unlike the normal factory. They are extremely expensive, and so because of that we are spending a lot of capital expenditure. So our cash flow is becoming very tight. So our CEO and our CFO wanted to do some cost cutting so that we can survive through this cash flow period, and so that we are more well prepared with all our factories when all the demands come. So if we can go over this difficulty at this moment, the future is going to lie ahead of Intel. Okay. Now, how is the engineering team dealing with it? So, the one of the things that Intel did was they offer, first of all, they offer the really old engineers for an option for them to retire. It's an option, okay, it's not a forceful one, right? They offer them for a retire because an old engineer are usually very high pay. So if they're willing to take up the options, they're gonna get one lump sum as their very nice retirement, and at the same time, it opens up the budget for us to fund the younger engineer. This is a very typical way of managing the finance of a corporate. It's not unique to Intel at all, right? All corporates do it in a similar way. So that is one way of how Intel is managing and retaining the talent. The other thing is we optimize our roadmaps. Maybe previously we may have defined many different branches of products that we want to sell or we want to make, but now we further optimize it. We go and ask our customer really carefully and listen to them really carefully. What is the product that you really want? I'm going to make that one product really good for you, so that I can cut short the list of my different branches, so I can optimize the use of my engineers, and so I can make really good products for you on time without any delay, right? So I optimize my roadmaps. There's also another things that we do. optimize our workflow. Remember just now I asked you, I told you about the question you have to keep asking yourself: how can I do this better, faster, and easier? So that's a question that we have been doing in an everyday basis, right? Do something easier so that we don't need to utilize so many energy from so many engineers. If the AI can help me to write this script, I don't need another engineer to write this script.
I think somebody asked you to comment on the competition between Intel and AMD here in the chat. So any comment on that?
It's a decade, multi-decade long competition. AMD, no doubt AMD is a very successful company. They were once at the verge of bankrupt about 10 years ago, until they had their current CEO, Lisa Su, who is a really technical person. She graduated with a PhD in physics, I think. Yeah, so she lead the company really well. They also came out with a brand new architecture called the Zen architecture, which was really efficient in terms of power and performance. So it's a wake up call for Intel. Like about the Zen architecture came out about less than 10 years ago, and Intel realized that we also need to improve, right? That's why we also begin to make changes in our product. It's a very stiff competition. Okay, we constantly remind ourselves in Intel here. We constantly remind ourselves that we no longer like the dominating era, like as dominating as the Pentium era anymore. So we must always remind ourselves to refine our design, our architecture. Every milliwatt of power, every picosecond of my design has to be better than before.
I hope that answers your questions about the competitions between Intel and AMD. So it's always an ongoing thing. Sometimes we are better, sometimes the competitions are better, and then you just need to continue to innovate and try new things, right? And then somebody asked, how much impact are the courses you have learned in your major help in your work? So I suppose possibly if you're not electronics or you're from another major, is it very important that you are from the electronics major?
I would say no. Most of the thing that I learned in my degree, it was a foundation for me to understand what I need to learn in Intel. The first day when I entered Intel, the first thing that I was asked to learn is the static timing analysis. It's something that I never learned in my degree. Okay, I have to learn it from scratch. But because I know what is gates, I know what is NMOS, what is PMOS, that serves as a foundation for me to be able to understand the next thing, which is the static timing analysis, right? And then subsequently, the next and next and next thing, right? So being an electronics student, if you take up the VLSI module, you will be in a slight advantage over other students who did not take VLSI, because you have the basic concept, and that concept will become one of the bricks, that will be essentially tiled up to become your technical foundation. Now, for those who do not have are not taking the VLSI module, right, or even students who are from mechatronics, right, don't be afraid, right? No worry about that. Intel do hire mechatronic students. Right? That's not a problem. You do have electronics background. We are entitled to hire you as well. Intel do not block the hiring of mechatronic student. The only disadvantage I can think of is you spend a lot of time studying mechanical. I just do not know how much useful will that be in a semiconductor industry, unless you are working in the assembly and manufacturing side. They do have a lot of robots and machinery there. Then maybe there will be a much better utilization of what you learn. But really, to be honest, what you learn in the degree is so much little if you compare to what required in the industry. So what more important is, again, back to the hands-on thing. Like how much hands-on, how much problem solving skill do you have? how creative you are in innovating out of your problems. I think that will be something much more important if you want to survive in your career, or you want to strive in your career. Yeah.
Okay. And then someone asked, is it beneficial to share their future career plans during an interview as a candidate?
Well, if you tell me your vision in your next 5 years, I do ask question like this. What do you see yourself in 5 years? I want to see how mature is the candidate. It's okay. I would think if I'm the interviewer, I would be interested to know how do you envision yourself. There are many people who really have no vision about themselves. They just think about tomorrow only. Okay. People like this, I can still hire them and coach them, right, to think ahead. But if you have the talent of thinking ahead of yourself, then I don't have to spend so much energy coaching you. Right? I can coach you the next level of things.
And then what is your view on starting a startup as an engineer in Malaysia, or somebody with an engineering background, I would say?
I'm not an entrepreneur. I don't think I'm the good person to answer this question, but I did been in a startup company before. As I mentioned, in the 11th year of my career, I made a detour. I joined a startup company. It's very hard. Okay, startup company is very hard. There's a saying in Hokkien. It's called "Bao Ga Liao." "Bao Ga Liao" means do everything yourself, right? So the day one I joined the startup company, I went and asked my peer, hey friend, do you have the flow or the scripts to get this done? My friend said, yeah, you go write it yourself. Write the script yourself, right? Write the flow yourself. So then I realized that, oh, really, I have to do everything myself, right? So that is a situation in startup company. Another fun experience I had was all those EDA tools that I use in simulating my circuit. They require license. For $1 million that the company pay, they only get a few license. And if I want to open the simulator, I have to knock the cube next door. Right? Knock. I say, hey, can you close your software so I can open? Right? It's a very scarce. The resource is very scarce in the startup company. You don't enjoy the abundance like this Intel environment. You don't get such a nice office, right? You're lucky if you have aircon, right? So the laptop is very old. That's how, because startup company is they need to control their cash flow, right? They need to pay all those employees every month, and their money comes from funding from the venture capital, right? So say the venture capital give them $2 million, and every employee engineer is not cheap, Engineers are very expensive. So when you pay 20 engineers to get this thing done, and if you divide by the amount of funding that you have, right, you probably can only survive 2 years, 2.5 years. And 2.5 years is just a blink of eyes only in the development of this sophisticated. So yeah, I do not know how to do a startup, but I have been in a startup before. Right? There was another fun story is that my salary did not come in for 2 weeks late. Then my CEO said, guys, wait patiently. Right? The money is coming. The money is coming. But I have no idea where is the money coming from because of my CEO look for the funding. I don't know what kind of difficulty he's experiencing. I just know that he always look very angry, right? That is how startup company look like. But lucky enough, my salary did come 2 weeks later. Okay, so you're like riding on a sampan. You are not riding on a ship. It's like a sampan. You are in a very fierce riding a sampan under a very fierce wave.
That's very interesting because you moved from Intel to a startup with I would assume to a very similar industry. And
Yeah.
then after that, you rejoined back Intel.
Yes.
Oh, okay.
Lucky enough that yeah, I rejoined back Intel.
Okay. So another student asked, which projects that you believe you have done a lot of projects, which one do you believe made you stand out as a fresh graduate? And what actually helped you put your foot through the door in the field, in your own opinion?
Let me share the first one first. One of the project that I feel the most proud of will be the one that went into the Apple, the Broadwell and the Haswell, 22 nanometer and 14 nanometer. In fact, I was so proud that I went to buy the MacBook Air. So I still own that MacBook Air until today, and my daughter is using it. Uh, yeah, it was a very proud moment for being part of that team. It was not an easy project. A story to share with you is that there was a timing path that I need to load the cache memory. Right, the logic says goes like this. Right, the CPU wanted some data. The CPU will query from the cache, and if the cache has the last recently used data, I must load the cache back into the CPU as quickly as possible. Right, every clock cycle that I expand on the on that path, that timing path, will become the direct performance impact to the end user, the gamers or whoever that is using the CPU. So that timing path was so hard that we literally printed out the whole layout and stick it on the wall of our meeting room, and everybody go into the meeting room to work. We call it the dungeon. Okay, everybody work in a dungeon. There will be food served to you every lunchtime. You don't need to go out. You don't need to step out of the dungeon, and you have to work there for long hours until you solve that timing path. So it was a very fun experience. I got a chance to work with some principal engineers during that time. I was just very young, right? I was just think it was like third to fourth year into my career, very young. But I got a chance to work on it because I'm crazy enough to propose. Right? I look very stupid. I propose a lot of stupid idea. Can we do this? Can we do this? Can we do this? Then the principal engineer will be like, nah, this one useless. Cannot. But because of the attitude of being creative, right? Keep thinking of the problem and keep proposing different silly idea, is what kept me in that team. So I was proud enough to be in that team, and that was one thing to share.
It's really interesting because I didn't realize that the MacBook Air actually uses Intel products, and then it was actually designed in Malaysia, right?
Yes,
So
yes.
that's really so today I know about it. So this is something to feel proud of, lah. Really, thank you for the sharing. And then we have got two questions and several others supporting the same question. Maybe or should I go Osama first? Osama, you wanted to ask a question? Because you keep raising.
Yes, doctor.
Please
Hi,
go ahead.
Osama.
I have two questions. First, can I employ an AI agent on a chip, an embedded chip? The second question, is there any differences between an AI chip and a normal chip? Maybe like an Apple Silicon chip or an Intel chip that can do AI. That's my two
Let me
questions.
answer the second question first. The second one seems to be easier. So
Okay.
AI, what we call AI today is essentially the deep learning network. It's a emulation of our human brain cell. Okay, we have human brain cell that will create a network that will help you to remember as well as understand. So if you want to know more about this deep learning, right, you need to go Google it yourself. It's one of the AI topic. There are many YouTube video that gives a simple description about it, but basically it's a lot of you just imagine there's a lot of nucleus that connects your human brain, right? Same things inside the computer. There's a lot of compute node that will represent the nucleus and the connectivity between the nucleus. And because of this nucleus, they perform very simple function of remembering something and connecting of each other, right? That's why the GPU architecture is very much suitable to do this, because the GPU architecture contains of many small computer that can perform this task. So that is part of the reason why NVIDIA was excelling in this area, because they were the GPU expert to begin with. So when you say Apple computer that has AI capability, essentially what they're saying is they put a dedicated neural processing unit side by side with their CPU, NPU, neural processing unit. Okay, so in the past we put Wi-Fi next to the CPU, then we put GPU next to the CPU. Now we put NPU next to the CPU. And so when you have NPU in your CPU, you can you can start loading a small AI model, like a very tiny llama, into your computer, and then it will be able to answer you the AI questions prompting directly on your laptop, even you are not connected to the internet. Okay, so Osama, the keyword for your second question is Neural Processing Unit, NPU. You can go Google it yourself. For your first question, can you employ AI agent in CPU? I don't quite understand this question, Osama.
I mean, not like a software. I need to maybe get maybe the GPU and embed my software inside the GPU, and maybe manufacture this GPU to drive maybe drones. So I don't have to install
Okay,
the
so
software.
essentially what you're asking, your question number 1 and number 2 is the same. The answer to your question is NPU, Neural Processing Unit. We have it in Intel chip since Meteor Lake. We have it in Arrow Lake, and we are going to have it more. We're going to have a larger NPU in our future product, and same goes to Apple. They are also having NPU in their Apple Silicon.
Thank you. I think that answered my question, Doctor. Thank you so much.
Great. Thanks, Osama, for your
Okay.
question.
I think somebody also asked the same questions about NPU, and then I think you answered already. And since you brought out NVIDIA, and then we have several questions on NVIDIA in the chat, because I think regarding the stock market and then the market share, because NVIDIA is rising, so what would be your view on this? And then I think they are very concerned about what is Intel's plan in recapturing the market.
Okay, let me answer the Intel part of the question first. I'm no expert in the stock market. So in terms of Intel, Intel has recently done a restructuring of our business. We divide our business into manufacturing, which is the part where we build factory to get ready to build the chips for the future. And then the other part will be our traditional business where we design CPU and SoC. Okay, so we divided this business into 2 divisions so that both business will report their own profit and loss. It's almost like 2 companies, almost like 2 companies. They will have their own profit and loss, and they will hold themselves accountable if they overspend their budget or they make a loss, right? So in that case, right, you will motivate each division or each business group to be responsible for their own spending and their profit. Okay, so by doing that, right, we basically make the manufacturing an independent arm, and that will have 2 effects. Number 1 is of course, the gross margin optimization, right? This group of people will now be more cautious about how they spend money. And number 2 is it will give the confidence to the customer that Intel is serious about being a factory. Okay. Now, before this, Intel factory only manufacture for your own product. We never manufacture for anyone else. Okay. So now Intel wants to become a factory for anybody who want to make a chip. Be it NVIDIA or Microsoft, whoever they want to make a chip can come to Intel if they want to. But they need to be confident enough, right? It's a very expensive business, right? Even if you just want to place one order, you need to pay a lot of money. So that's why the confidence to the customer is very important. So Intel is doing a few things to bring the confidence to the factory. Number 1 is we isolated the profit and loss. It shows that this is an independent entity. Is a high integrity, right? I will not steal your information and put it in my own Intel product. Okay, this will never happen, right? Secondly, is the Intel is investing in building the factories. Okay, so once you have the factories, you can then make more chips. If you don't have the factory, what can you make, right? So we are burning our capital expenditure. This is a public news. You can read it anywhere. We are building factories. Number 1, number 2, right? And then number 3 is we are trying to prove ourselves that our process node is good. Okay, how are we going to prove that? We design our own chip in this process node, and then we manufacture it. We produce it in high volume. We show the high yield. Remember the yield, YIELD. That means the probability of success silicon. We show the high yield. That will again give confidence to the customer that, oh, Intel process is not a joke. It can really produce high performance, high yield product. So those are the 3 things. So once all these once the customer begin to purchase the volume from the Intel factory, we will make revenue, we will make profit. And I'm no expert in the stock market, but as far as I learn, if the profit goes up, the stock price goes up. That's it. Simple as that.
Thank you so much. So we still see a lot of hope. I think in all businesses is the same, right? Making decisions, changing, diversify, and then tweaking the business model and all that in order to survive. Thank you very much. And then I think we would have one question. So regarding the part-time internship, you will be sharing with us on how to apply. I think some of the students are interested. So possibly I can get that information from you later on.
Okay.
Any further questions? Because we are like 40 minutes over time. So this is
What an
very
exciting session.
Yes. But if you have further questions, I think that we cannot cover today, feel free to send them to me and then I'll forward them on. Hopefully you still have time to answer them. Otherwise, I think we can conclude today's session. Right? Thank you so much